is essentially a solid formed out of a reaction. I'm not going to do that again. Whoopsies. Why is that doing that? That's a new idea here. There we go. So precipitate is something that's formed out of a reaction. Blah 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 blah. Precipitates are the solids. These solids are insoluble in water, which means they don't dissolve in water. Here are our rules. Now all these guys here plus NH4, but you're probably not going to see NH4 plus, are all soluble no matter what. Doesn't matter what happens, they're going to be soluble. And so that means that they're really easy to check, because the second you see one of those guys, you can just say, well, that's going to be soluble. These ones down the bottom, these are our sometimes soluble, or mostly soluble. So that means if you see sulfate or chlorines or bromines, they're probably soluble, but you just got to be careful. You got to be careful because you got to make sure you avoid what I've been calling them is the deadly trio, which is silver, mercury, and lead. Silver, mercury, lead. Ag, Hg, Pb. If it ends in G or B, it could be part of the deadly trio. Now, again, remember, you're allowed to have this open during the test. So I'm not trying to saying to you have to memorize it. I'm just saying, hey, these are the ones you've got to be careful of. And like, as I've been going through, I've become quite familiar with those. If I see Ag, I'm like, ooh, that's one of the bad ones. The only weird exception is that sulfate also has calcium. Calcium is also insoluble in sulfate. So if you see calcium sulfate, that's an exception. I actually looked up mercury sulfate to see if mercury sulfate was soluble. Mercury sulfate also isn't soluble, but it's kind of like a borderline example. It kind of reacts with water, and that's why we don't usually deal with it. But I'm not going to discuss that yet, especially because I've got some more important things I want to talk to you guys about. And I've only got 20 minutes to do it. These guys are always insoluble unless they're bonded to these. They're always insoluble unless they're bonded to sodium, potassium, and lithium. And we know that's the case because sodium, potassium, lithium are always soluble. So you only have to remember is those guys are always insoluble. Yeah, okay, cool. So these are the solubility rules. You can keep talking about this. Okay, thanks for your permission. I'm a bit confused. Someone just sent me something in chat, which is a bit confusing. So the next thing I wanted to do is I wanted to talk about this. So what I decided to do is I decided to pop open 5 examples here. Now these examples are examples. Okay. This one is sorry. So I'll just look at this in a second. Sorry, Lena. I'll look at that in a second. So these are 5 examples that I wanted to pop open just because I said I found a couple of people struggling with them. And what these examples are is they're examples of this form. I will often get asked is, listen, is this a precipitate reaction? And if so, if this is a precipitate reaction, what is the precipitate? Now, what do precipitate reactions look like? Precipitate reactions always look like, precipitate reactions will have this going on here. Now, what is this going on here? This is called a double displacement reaction. Why is it called double displacement? Because both of them are swapping partners. The calcium swaps partners with the potassium. You can see that by watching the calcium and potassium go down, but the carbonates and iodine slide across. And how do you check if this is a precipitate reaction? Well, what you do is you slide these across like this. You swap their positions. Now, obviously, if you're doing this, you won't be able to do this fancy animation in a test. But what you would do is you would just say, okay, well, let's work this out. We'll take calcium. It's bonded to iodine. Let's swap that for carbonate. Let's swap the end of iodine for the end of the other one. So it's going to be carbonate. The other one is going to be, we're going to take potassium, and we're going to swap that carbonate for an iodide. And that's how I get them. I just swap the ends. Instead of writing carbonate, I write, instead of writing carbonate, I write iodide. Instead of writing iodide, I write carbonate. And I just swap them like this. Now, after that swap, after that double displacement, we get two products. Now, to check if it's a precipitate reaction, you just got to check, are both products soluble? Well, let's check. Okay, we've got calcium carbonate. Carbonate is on our list. Carbonates are always insoluble unless they're bonded to sodium, potassium, or lithium. This is calcium. It is not sodium. It is not lithium. It is not potassium. This guy is none of those. So I can straight off say this is insoluble. This will be our solid. This is our precipitate. And I've done that just because I've seen, well, what is this bonded to? It's bonded to carbonate. Carbonate is over here. Calcium, Ca. You might be like, oh, well, calcium, where is this on the list? There is no calcium on this list. You can have a quick look for it. Well, there's one calcium here. But that only applies if it's bonded to sulfate. That's not sulfate, that's carbonate. They're in line. But you should always check to see if you can find them. What about potassium iodine? Well, we already know that this is iodide. This is probably going to be soluble, but we can just quickly double check. Iodides here are only insoluble if it's bonded to the deadly trio. This is not part of the deadly trio. Potassium is not, so this will be soluble. So that's how I check if something is insoluble or insoluble. So this is a precipitate reaction because it makes an insoluble precipitate. How did I find that precipitate? I just compared the last, and usually you'll notice how these are all minuses, right? These are all looking at the green part of the, the molecule. So that's actually what I would usually start off with, just looking at that green part. And then that helps me quickly find out what's going on here. So yeah, that's how I know calcium carbonate is insoluble. Now, I've got a couple more examples of this up my sleeve. So if I've got about 10 minutes left, I'm going to do some of those other examples. Let's look at example 2. Example 2 has got chromium bromide and mercury nitrate. So if I swap these around, I'm going to end up with chromium nitrate by getting rid of the bromide and writing nitrate. And for the other one, we're going to have mercury, get rid of the nitrate and write bromide, mercury bromide. So that's exactly what you get, chromium nitrate and mercury bromide. Now it's time to check if these are soluble or not. Okay, this has got a nitrate. Well, guess what? All nitrates are soluble, so I don't even need to look up whether chromium is soluble or insoluble. I know that it's soluble. Now that means that in this case, our mercury bromide, if this is supposed to be a precipitation reaction, is probably a precipitation reaction, but we should check. Bromides. Bromides are usually soluble, but they are insoluble if it's bonded to Ag, Hg, and Pb. Silver, mercury, or lead. Hey, mercury, that's one of our lists. That's on our list here. Now, if you weren't aware, mercury is Hg, silver is Ag, and lead is Pb. So if you're not familiar with what those are, that's what those are here. That's why they're all silvery metals. So lead, silver, and mercury are all silvery kind of metals. You've got mercury, which actually was originally called liquid silver. So yeah, that's why it's called Hg instead of Ag. Ag was for Argentinian, whereas mercury, I think, is hydro-Argentinian because they thought it was like liquid silver. So that's why they both got end in G, whereas lead is completely different. So that means mercury bromide, mercury is one of the deadly trios. So therefore, we say this is insoluble. This will make a solid. This is our precipitate. Questions? Queries? Maybe? Guys, if you got any questions or anything, you need to just let me know in chat really quickly because I don't have a lot of time to dwell on these. I've got 5 examples. I've gone through 2. Let's keep going. The next one is nickel chloride with sodium sulfate. So this is going to swap. The nickel is going to lose the chloride and it's going to gain the sulfate. Whereas the sodium is going to lose the sulfate and gain the chloride, sodium chloride. Now, let's swap them around. Whoa, do-si-do, switch your partners. This is double displacement. Both of them get swapped. Both of them still have partners at the end. That's another way you can check the double displacement versus single displacement. Single displacement, one of them won't have a partner at the end. So that's a good way to check. Now, let's do this. So we're going to look at the sulfate. Sulfates here. Now, sulfates are usually soluble unless it's bonded to silver, lead, or calcium. Nickel is none of those things. Nickel is not silver. Nickel is not calcium. Nickel is not lead. So that means this is soluble. Okay. What about sodium chloride? Well, chloride's down here. Chloride is soluble unless it's bonded to silver, lead, or mercury. Well, sodium is not silver, lead, or mercury, so this is soluble. That means that both of our products are soluble. That means there's no precipitate here. So that means this is not a precipitate reaction. Now, I wanted to throw in one curveball. So this is our one sort of curveball here. And it's just, you know, hey, guess what? Just because you've got a reaction doesn't mean that it's like, you know, just because you've got a reaction, a double displacement reaction, doesn't mean that it's going to be as a precipitate reaction. So this is not a precipitate reaction. There is no precipitate form. Both of the products are soluble. Now, if that was calcium sulfate, we'd be in for a different story. But luckily for us, it's not calcium sulfate. So therefore, we just say it's soluble. There are some interesting chemical things we could look at with regards to temperature. Maybe nickel sulfate might not be soluble at certain temperatures, but we're not doing that because we're not in year 11 chemistry. We're just year 10s. We don't have to worry about that. We just say it's soluble and we're done. Let's look at example 4. Oh, and some of you might be saying, well, what if I get this in the test? You just write down it's not a precipitate. You just write down it's soluble. Both products are soluble, so it's not a precipitate reaction. Done. Just write it down. If it asks for what is the precipitate, you say there isn't one. Easy. Now, next one. You see, well, what's different about this one? Straight away, you guys should see, hey, where did the names go? For the last 2, I decided to replace them with the symbols. And it's like, okay, but the symbols shouldn't make much of a difference here. We've got barium sulfate and sodium hydroxide. Now, if you're not comfortable with what the names of these things are, well, again, this is why you've got these symbols. So if I swap these around, the barium is going to get the hydroxide, and the sodium is going to get the sulfate. Now, these are not the proper balanced forms of these terms, but all I'm trying to show you here is sodium lose the hydroxide, gain a sulfate. So I just wrote NaSO4. For the other one, the barium loses the sulfate, gains the hydroxide, barium hydroxide. We're going to worry about balancing them later on. That's not important. In fact, we don't even need to worry about how to balance these ionic formulas because that was the skill that was assessed term 1. So luckily you don't need to be able to do this. You just need to be able to tell me out of barium hydroxide and sodium sulfate, which of these are soluble and which of these are insoluble. Well, let's have a look here. Barium hydroxide, well, it's got a hydroxide. OH is here. Here's OH. Yeah? So hydroxides are pretty much always insoluble unless they're bonded to sodium, potassium, and lithium. Barium is not sodium, it's not lithium, it's not potassium. So it's not bonded to Na, K, or Li. So as we say, this is insoluble. This is our solid. This is our precipitate. Now, just to be sure, let's just quickly take a quick look over this one. Sodium sulfate. Oh, sulfate again. We better be careful here. Sulfate. Sulfates are soluble unless bonded to silver, calcium, or lead. Sodium is not silver, calcium, or lead. So this is going to be soluble. It's going to dissolve in water. So that's how we can quickly look at it when we deal with symbols. When you're dealing with symbols, all you got to do to deal with symbols is just compare the symbols. Instead of looking at the names, look at the symbols. Now, the last one here that I've got for example 5, which is going to be my last one here, is zinc chloride. Now, this has got some balancing problems here, but I will just ignore it at the moment. We're going to take zinc chloride, we're going to take zinc, we're going to take lithium, we're going to take zinc, we're going to get rid of its current partner and replace it with sulfide. The lithium, we're going to get rid of its current partner and replace it with chlorine. Zinc sulfide plus lithium chloride. And if you balance it out, you actually end up with 2 lithium chlorides, but we don't care about balancing in a moment. We only care about solving this. So let's have a look here. Zinc sulfide. We've got sulfide, 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 sulfide. Sulfate? No, it's not sulfate, it's sulfides. Carbonate, phosphate, sulfide, S. Ooh, they're pretty much always insoluble unless it's bonded to sodium, potassium, and lithium. This is not sodium, potassium, or lithium. So that means this sulfide is insoluble. This is probably going to be our solid. This is our precipitate. Now let's check the other one. Lithium chloride, lithium chloride. Now lithium chloride is a chloride, so here's chloride, and it's soluble unless bonded to AgCl, Pb, but lithium is not one of those, so that means it is soluble. Or we could completely ignore this. We know that all lithium compounds are soluble, so I don't even need to think about that, really. I know all lithiums are soluble. I know all sodiums are soluble. And for this one, I know all sodiums are soluble. And I know all, this one was a bit, we know all nitrates are soluble. So that's why I skipped that first one. All nitrates are soluble. And the last one we know, all potassiums are soluble. So that was the trick here, that you could quickly go through to find out which one's a soluble one. Now, with all of these examples, the fastest way to do them is sometimes just to figure out, you know, which of the 2 species is soluble, and usually the other species is insoluble. And the other species is usually your precipitate. But that's why I did show you guys this one here, just to show you, hey, just because you definitely know this is soluble, NaCl, Na is always soluble, so therefore this must be soluble, doesn't mean that this is 100% your precipitate. You can see here in this case, it's not a precipitate at all. It just sort of looks like one. So this is not a precipitate reaction. Now, I have a quick thing in the chat. I'm going to do this. Were there any questions here, by the way, before I discard everything on this thing? Were there any questions, any queries? Anyone, when we go back over one of those 5 examples? as I said, I think a lot of people, and you guys are allowed to have access to it, so you guys can do this exact same process in the test if it asks you to do it. But yeah, I found a lot of students struggle. A couple of you guys struggle with these kinds of solubility rules and how to apply them. So hopefully I've cleared that up. Now, there was one question in chat, which was, I just wanted to let you know that even in the class, I can't seem to access the YouTube video that explains the lesson. So, okay. What if nitrogen is bonded with carbonate? Okay, so firstly, let's start with Lena. The video about catalysts, I don't know why. I assume you're meaning the video in the catalyst lesson. I assume you're talking about the video in the actual style. Yeah, that's what I thought. Don't worry too much about that. I'll give you a quick explanation of a catalyst. Like, I can give you a quick explanation of the catalyst in like 2 minutes left. I'll answer Alex's question right now. So Alex, you said, what if nitrate is bonded with carbonate? Well, guess what? Nitrate can't bond with carbonate. The reason why nitrate can't bond with carbonate is because nitrate's a -1 charge, and carbonate is also a -1 charge. So even though these look like just the only exceptions, nitrates and carbonates cannot react because they're both minus charges. Now, ammonium carbonate, so NH4, ammonia carbonate, would probably also be soluble as well, even though ammonia isn't on our list. I'm not going to be hitting you guys with ammonia probably in the test. I just thought I'd add that in there. Really quickly for you, Lena, I know that this is not on the, I know you can't access it, so I thought I might quickly give you just for a little bit of revision. What is the dealio with a catalyst? The dealio with a catalyst is catalyst increases the rate of reaction, not by increasing the amount of collisions. Like a lot of these other examples, and I briefly talked about this, a lot of these other examples, let me open up this. A lot of these other examples increase the rate of reaction by just making more collisions. What they do is they just say, well, let's take the box and say when this collides with this, we'll get a reaction. So therefore, if we want to make sure that there's lots of reactions, it makes sense to have a lot of different kinds of stuff. That's increasing the concentration. By moving these around, by also increasing the surface area, does the same thing. You're crushing them up, you're making them more available. By heating them up, you're making them collide more. But catalysts don't do that. They don't increase the amount of collisions. What they do is they say, well, if two things are going to react, we're going to make sure that they're the correct orientation. So it makes sure that they're in the correct orientation. That's how they make it. And because they're in the correct orientation, that actually has a special kind of thing. And because you're forcing them to be in the correct orientation, what that means is that what that means is that the activation energy, I don't know who I just let in there, I wasn't even looking. The catalyst will make it easier for the reaction to occur, which lowers the activation energy. So that's how you can think about it. What a catalyst does is because it's lining those reactants up perfectly, you actually don't need that much energy in order to get the reaction to work. So it makes the activation energy very, very small. You don't need a lot of energy to get a reaction started. That's what it does. And so that means every time a reaction happens, it's more likely to go forwards because you've pretty much set it up so it's going to work. That's how this sort of explanation sort of works. And then we talked a bit about what an enzyme is. An enzyme is pretty much exactly the same thing as a catalyst. The only difference is that it works in the human body. But yeah, that line at the bottom there is, I think, the line that best describes catalysts. Catalyst makes it easier for reaction to occur, which lowers the activation energy. And a lower activation energy just means you're more likely for reaction to occur. Okay, no, okay, good question. Thank you. Don't worry, Lena. There is no. Lena was a bit concerned. She's messaged me privately. I'm just gonna let you guys know. She's a bit concerned. It's like, oh well, if there's a question that I need to watch YouTube videos on the test, I'm not going to be able to do that to answer a question. I'm like, that would be a good point. And if you had to do that, that could be a thing that would maybe make doing this test very, very difficult. Luckily for you guys, there is nothing like that. All of the questions are just questions. They're just written down there. There is no, I don't even think there's any real interactive things. We've got to double click to put things in there. All of the questions with regards to balancing or with regards to soluble or like precipitation reactions, they're all done in like tables, the same way that the questions were done in the other example.